Okay, today we are going to be constructing something that's called the unit circle. And so, as you can tell by the name circle, we're going to be working with a circle. So, let's first of all remember what the equation of a circle looks like. So, x minus h quantity squared plus y minus k quantity squared equals r squared. The center of your circle is located at HK, and the radius of the circle is R. Now, for this particular equation, we are going to use a radius of 1. That's why we're going to call it the unit circle, because its radius is going to be 1 unit. And the center is going to be at the origin, which is 0, 0. So if we go ahead and plug that in, we're going to have x minus 0 quantity squared plus y minus 0 quantity squared equals 1 squared. Well, we don't need all of these zeros, so basically the equation that we're working with is x squared plus y squared equals 1. So that's the equation of the unit circle. So since it has a radius of 1 and we're starting at the center, we can go ahead and label all of the intercepts as we go around. So right here, this one's going to be 0, 1. This one's going to be negative 1, 0, and down below is going to be 0, negative 1. Okay, so we've got our equation, we've got our intercepts graphed. We're just going to go ahead and explain the scale of this circle. Normally, when we're graphing on our graph paper, we just count each grid mark as 1. But as you can see, there are 10 grid marks before I wrote number 1 on that circle. So basically what our scale is, we're counting by tenths. 1/10, 2/10, 3/10. There's 10 grid marks until we get to 1. So our scale is counting by tenths on this. So each grid mark is 1/10, not 1. What we're going to do now is we're going to take, remember those special triangles, those 30, 60, 90s, and 45, 45s? We're going to actually take those and we're going to graph them inside this circle, inside the unit circle. So since our unit circle has a radius of 1, we're going to put this 30, 60, 90 triangle inside there, and we are going to use our hypotenuse for that 30, 60, 90 triangle as 1. That's going to correspond with the radius of our circle. So if you recall from our patterns, the side opposite the 30 is a half the hypotenuse, and then the side opposite the 60 is a half times the square root of 3. So this is going to be the square root of 3 over 2. So what I'm going to do is we're going to graph this particular triangle that we just put the labels on over here in the unit circle. So I would get my protractor out and I would measure 30 degrees. So if I get my protractor out and I measure 30 degrees, then I'm going to draw a line to where I think that point is. So I think it's about right there. And then what I'm going to do is I'm going to draw that straight down and make my triangle out of that. Okay. Now I'm going to go ahead and put the side lengths in. So this was a radius of 1. This length right here was the square root of 3 over 2, and this length was a half. Now what we're going to do is we're going to put a lot of triangles into this unit circle. And to write these length measures and these angles inside these triangles that we're drawing is going to be really messy. So what we're going to do instead is we're going to write all this information outside of the circle. Okay, so instead of writing everything inside the triangle, I'm going to put my lengths as an ordered pair. We moved over the square root of 3 over 2, and we went up a half. So we're going to write that as the square root of 3 over 2, comma, a half. That represents the side lengths of this triangle. So remember, we went over the square root of 3 divided by 2 and up a half. That's where those points came from. That's how we created the lengths of that triangle. And remember, the angle that we rotated was 30 degrees. So I'm just going to put 30 degrees out here to the side. Okay, now we're going to do it again, but this time we're going to use the 45-45 degree triangle. So if you remember, in a 45-45, if I'm going to use the hypotenuse as 1, to get to the side opposite, I need to divide by the square root of 2. So if I want the legs, I have to take the hypotenuse and divide by the square root of 2. So 1 divided by the square root of 2, rationalize that, and you end up with the square root of 2 divided by 2. So since it's a 45-45, those measure are the same. So I'm going to take this 45-45 degree triangle and I'm going to move it over here into my unit circle. So once again, I am going to move to the right what I think the square root of 2 divided by 2 is. You could type that in your calculator and get a decimal approximation. So the square root of 2 divided by 2 is about 0.707. So I'm going to be moving right 0.7, and then I'm going to go up about 0.707. So that puts me right here. That's a point on the circle, on our unit circle, and that point is the square root of 2 over 2, comma, square root of 2 over 2. I went over the square root of 2 over 2, which is about 0.7, and up that same distance. Okay, I'm going to go ahead and draw that radius in, and now we've got that 45-45 degree triangle inside our unit circle. And the angle measure out here is 45 degrees. Okay, now we're going to do the same thing again with this triangle at the bottom left here. It's basically a 30, 60, 90 triangle, but it's oriented different. But because we're working on the unit circle and the radius of the unit circle is 1, that means the hypotenuse of this triangle is going to be 1 again. The side opposite the 30 is a half the hypotenuse, and the side opposite the 60 is a half times the square root of 3. So that's going to be the square root of 3 over 2. And so I'm going to draw that triangle in to my unit circle over here on the right. So I'm going to go over a half, which is about 5/10, remember, because our scale is tenths. And then I'm going to go up the square root of 3 divided by 2, which is going to put me right here. This is going to be another point on my unit circle. I'm going to go ahead and draw in that hypotenuse. So I went right a half and up the square root of 3 over 2. And that was 60 degrees was the angle that we would rotate to get to that side. As you can see, we've drawn in 3 reference triangles that have given us 3 points on our unit circle, 3 new points. This first point right here was at the square root of 3 over 2, comma, a half. The second point was right here when we rotated 45 degrees and we got the square root of 2 over 2, comma, the square root of 2 over 2. And then our third point was when we rotated 60 degrees and we got 1/2, comma, square root of 3 over 2. So we've added 3 more points to our unit circle besides the points that are on the intercepts. What we're going to do now is we're going to take all 3 of those triangles and we are going to put them in the other 3 quadrants. So if you notice, there's multiples here of angles. So we started right here at 0 degrees. If you think of this as 0 degrees at the 1, 0 point, this next angle, this red one right here, would be 30 degrees away. And then if we skip the 45, we're going to go to 60 degrees. These are multiples of 30. 0, 30, 60. Then the next intercept is at 90 degrees. So then I feel like the next one I want to do is 120 degrees, 150 degrees. Then we'd be over here at 180 degrees. Keep going, 210, and then 240, and then 270. We'd be down here at this intercept. 300, 330, and then we'd be all the way around again at 360. So that's what we're going to do. I'm going to take a minute and I'm going to fill in the rest of these triangles all the way around. with their angle measures. Then I'm going to do the same thing with the 45, 45. So I'm going to take a minute, draw all those in, put the labels, and then we can see what it looks like. Okay, I've drawn in all my triangles, and as you can see, I've kind of created this pretty bow type picture. But I want you to pay special attention to the signs as I was drawing these triangles. As I was moving left in the second quadrant, and then I was going up, notice how my sign is a negative as I'm going negative a half and up a positive square root of 3 over 2. And then as I went into the third quadrant to make a triangle, every time I moved left, so if I was doing this blue one again, as I moved left a half and then I moved down minus the square root of 3 over 2, in my ordered pair, I'm keeping track of that because that's how I got to those points. I went minus a half and then minus the square root of 3 over 2. And then in the fourth quadrant, I moved right, which is a positive number, and then down, which is a negative number. So I have a positive 1/2 and then minus the square root of 3 over 2. So as you're moving around in your quadrants and putting your points in, you need to keep track of the signs so that you'll know what quadrant you're in by positive and negative signs of your ordered pairs. So now on our unit circle, we've got all these points around our unit circle, but how does that help us out? Well, we're going to use those reference triangles that we made, and we are going to figure out how does that relate to right triangle trig. That's the whole goal here. We're going to be using right triangle trig and these ordered pairs to find sine, cosine, and tangent. We could find secant, cosecant, and cotangent just from looking at this picture of special angles. Unit circle works with special angles. It works with all the 30, multiples of 30s, and multiples of 45s. The last thing we probably should do before we move forward is we probably need to have all of our angles, not only do we need them in degrees, but we probably should put them in radians. So you can do this a couple of ways. You can go around and convert every angle. So you could say, okay, 30 degrees, if I was going to convert that, I would multiply by pi over 180. Reduce that and you end up with pi over 6. So 30 degrees is the same thing in radians as pi over 6. Well, you could go around the unit circle and you could do every one of those and convert them, or we can just use our fractional parts. Remember, these are multiples of 30 as we go around the unit circle. So if 30 degrees is pi over 6, that's considered 1 pi over 6. Then 60 degrees, that's my next multiple, must be 2 pi over 6. So go ahead and reduce that, and that would be pi over 3. The next multiple that you're working with would be the 90. So that one's pi over 3. Well, let's keep how we were counting. Maybe we should just count them all the way around and then reduce them when we're done. So let's go back to 30. 30 was 1 pi over 6. 60 was 2 pi over 6. That means 90 is 3 pi over 6. 120 would be 4 pi over 6. 150 would be 5 pi over 6. 180 would be 6 pi over 6. And then 210 would be 7 pi over 6. 240 would be 8 pi over 6. 270 would be 9 pi over 6. 300 would be 10 pi over 6. And 330 would be 11 pi over 6. And then we'd be back here at 360, which is 12 pi over 6. Okay, take a minute, go around and reduce all of those, and then we'll do the 45 degrees. Okay, now we are going to do the multiples of 45. If you notice, we could count some multiple angles of 45 as we go around the unit circle. So let's go ahead and convert 45 to radians to see what fractional part that's going to be. So 45 degrees times pi over 180 is going to equal pi over 4. That's our radians. 45 degrees is equal to pi over 4 radians. So we are going to count by pi over 4. And we're only going to count things that are multiples of 45. So if I start right here at 45, the next multiple of 45 would be 90. And then the next one after that would be 135. Then we'd come down to 180. Then we would go down to 225, 270, 315, and then back around to 360. Those are all our multiples of 45. So we're going to go ahead and count those out like we did the pi over 6. That way I don't have to go and convert all these individually. I'll just count out their fractional parts. So this is 1 pi over 4. 90 degrees would be 2 pi over 4, which reduces to pi over 2. And then 135 would be 3 pi over 4. And then 180 would be 4 pi over 4, which reduces to pi. Then 225 would be 5 pi over 4. And then 270 would be 6 pi over 4, and that reduces to 3 pi over 2. 315 would be 7 pi over 4. And then we'd be back up at 360, which is 8 pi over 4, which reduces to 2 pi. So as you can see, we've got all of our ordered pairs in here. We've got all of our reference triangles. We've labeled all of the angles that we've rotated in degrees and in radians. A lot of information in there. Um, you're going to want to have this information for easy access. So as you're making yours, if it's a little messy, you may want to just print one off the internet so you can read everything. So here's one that I got off the internet that just kind of shows everything with all the correct signs, angle measures, radians, everything's there. So you can compare your unit circle to this one to make sure that everything is legible and you can find all of your ordered pairs and all of your angle measures. Okay, now what we're going to do is we're going to figure out how do we use these reference angles or reference triangles to figure out exact values of our sines, cosines, and tangents. So this particular question says find the exact value of the sine of 135. So remember, when we rotate an angle, we always start from the positive x-axis and we rotate. So this is rotating positive, and 135 would put me right here. Now, if I were to highlight the triangle that I drew on my unit circle, it would be this triangle right here. So whatever you have on yours, this is the triangle you're looking for. This is the ordered pair associated with it. So right here, this is telling me that this side right here, when I moved left, its side length, I didn't put it in my triangle because it was really messy, remember? That's why we put them as ordered pairs over here. So this side length is minus the square root of 2 divided by 2. And this side length over here is a positive square root of 2 divided by 2. Now, our reference angle, we didn't draw any reference angles in here, but this highlighted triangle that I've got drawn here, if I were to put its reference angle in, I'm going to call that theta prime. Right there at the origin, this is my reference triangle. Okay, what I'm going to do is I'm going to move this triangle over here to the right so we can see what's happening. So over here to the right, it kind of looks like this. We went left, minus the square root of 2 over 2, and then we went up the square root of 2 over 2 to get to this point. We rotated 135 degrees. This is my reference angle right here, which is a 45-degree triangle. That's why we built it in the unit circle. I don't have to guess. That was my 45, 45 that I put in every time. So the question is find the sine. Now remember, this was a unit circle and our radius was 1. So remember, the radius is the hypotenuse, so our radius is 1. If you were to pick sine out of this reference triangle, you would say sine is, by definition, the opposite side. So if I'm going to say the sine of 135 degrees, it's going to be the opposite side, square root of 2 over 2, divided by the hypotenuse, which is 1. Well, dividing by 1 is not going to change its value. So the answer is square root of 2 over 2. Now, I want you to notice in our ordered pairs, right here, the square root of 2 over 2 was equivalent to the answer we got. We took the opposite side and we divided it by the hypotenuse, which was 1. So that's the square root of 2 over 2. Okay, just kind of think about that for a minute. Let's try another one. Okay, this time we're supposed to do the cosine of 4 pi over 3. So once again, we want to rotate all the way over to 4 pi over 3. So 4 pi over 3 is going to be in the third quadrant. So we're going to start here on the positive, and we're going to rotate all the way around to right here. That's 4 pi over 3 radians, or the same thing as 240 degrees. The reference triangle that we made with that is this triangle right here that I've highlighted. Now, our ordered pair, this point, said that we went minus a half. So we went minus a half, and then we went down minus the square root of 3 over 2. Okay, once again, let's just move this reference triangle over here so we can see what we're doing a little bit better. Here's my reference angle. I should know what that measurement is by the triangle I drew. This angle right here is, my reference angle should be 60 degrees. So let me redraw that. Since I know what my reference angle is, I'm going to go ahead and draw it in there. So here, I know this one's 60 degrees. And we went left a half. We went down minus the square root of 3 over 2. And the question is, and our hypotenuse is 1 because the radius of the unit circle is 1, so our hypotenuse is always 1. It says find the cosine. Well, by definition, so if I'm going to look for cosine of 4 pi over 3, definition is adjacent side over hypotenuse. Well, dividing by 1 doesn't change its value, so that's a negative a half. So remember, once again, I want you to think about my answer was a half, and in the ordered pair that I started with, here's the negative 1/2. The answer was a negative half, not a half, negative a half. And here was the negative 1/2 in our ordered pair. Okay, just keep thinking about that. Let's try another one. Okay, so this says find the tangent of 330 degrees. So once again, we got to rotate. We always start on the positive x-axis. We rotate all the way around to 330 degrees, which puts me right here on this terminal side right here. Well, let's go ahead. Here's the point it put me at. Let's go ahead and draw that reference triangle that was associated with that point. Here's the reference triangle. I should know what that reference angle is based on the triangle that I drew. That reference angle is 30 degrees. So once again, let's come over here to the side and draw it so we can see a little bit better what's going on. So this is 30 degrees. And the directions to that point, I went over the square root of 3 divided by 2. And I went down a half. Okay, so we want to do tangent of 330. And I forgot to put my hypotenuse in. Remember, we're on the unit circle, so the radius is 1, so the hypotenuse is 1. So tangent in word definition is opposite over adjacent. So if I'm standing here at 30 at my reference angle from my reference triangle, then the opposite side is a negative a half. and the adjacent side is the square root of 3 over 2. Well, since these are both divided by 2, these two are going to reduce, and you're going to end up with a negative 1 divided by the square root of 3. So you're just going to go ahead and rationalize that, and you end up with minus the square root of 3 over 3. So the exact value of the tangent of 330 degrees is minus the square root of 3 over 3. Okay, so next one is to find the sine of pi over 6. So once again, we want to rotate pi over 6. We want to find that on our unit circle. We always start on the positive x-axis. We rotate to pi over 6, which would be right here. This is the terminal side. We're going to draw in the reference triangle. That's what we drew when we made that ordered pair, that point right there. I should know what this reference angle is by how I drew it. This reference angle is 30 degrees. So I'm going to come over here. I'm going to set it up again over here so we can see what's happening better. So this is 30 degrees right here. I went right the square root of 3 over 2. I went up a half. Hypotenuse is 1 because the radius of the unit circle is 1. All right, we're going to answer our question now. The question said, find the sine, the exact value of the sine of pi over 6. Well, our definition of sine is opposite side over hypotenuse. Once again, dividing by 1 is not going to change that value, so we're going to end up with a half. So the sine of pi over 6 is a half. So I'm trying to make a connection here. So if this answer is a half, and how did that relate with this ordered pair over here? There's a half right there. Okay, we're going to try one more, and then we're going to wrap this stuff up. Oh, I think there's a couple more, and then we're going to do a big wrap up of how are these values correlating to the ordered pairs. Maybe some of you have already figured it out by now. Okay, this time we're going to rotate a negative 135. So if you were to look here on your unit circle, rotating a positive 135 would put you right here on this terminal side. But that's not what I want. I want a negative 135. So we're going to go the other direction. Even though our angle measures on our unit circle are all positive, we're going to rotate a negative 135, and that's going to put you right here for this terminal side right here. Okay, let's draw that reference triangle in and figure out what's going on. We should know what our reference angle is. It's right here. This is my reference angle right here. It's a 45. How did I get to this point? Well, I went left minus the square root of 2 over 2, and then I went down minus the square root of 2 over 2. So there's our triangle all set up. We're going to stand here at the reference angle, and we're going to find cosine. And remember, our hypotenuse is 1. We're on the unit circle. So cosine of a negative 135 degrees is equal to the adjacent side, which happens to be minus the square root of 2 over 2 divided by 1. Well, dividing by 1 doesn't change its value, so you end up with minus the square root of 2 over 2. So how did that answer relate to our ordered pair? When we were doing cosine, we got this answer. Cosine actually matches up with this one. So I don't know if you guys are kind of catching on, but anytime I was doing a cosine, the answer always turned out to be the x value. Anytime I did a sine, so let's come back here to the sine, the answer turned out to be the y value. So there's a reason for that because we did our hypotenuse as 1. When we're dividing by 1, we can just pick the opposite side or the adjacent side to find the sine or the cosine because we're dividing by 1 every time. The tangent was a little trickier. I don't know if you guys recognize that. But remember, tangent was opposite over adjacent. Well, here's my -1 right here. -1 is right here. And I'm dividing that by my square root of 3. So opposite over adjacent, those are going to divide. So you're going to be able to look in all your points and be able to tell the sine, cosine, and tangent. And then how does that relate to secant, cosecant, and cotangent? Well, it's just going to be the reciprocals of everything. Okay, let's try one more. So this one's going to be the sine of 7 pi over 6. So we're going to go to 7 pi over 6 on our unit circle. So 7 pi over 6 is right here. So we're going to rotate to 7 pi over 6. This is the terminal side. We're going to build, we should have a reference triangle there. You should have on your unit circle a reference triangle. Right here's a reference triangle. So I'm going to move it over here. This reference angle is 30. We're not really needing that right now, but I went left minus the square root of 3 over 2, and I went down a half, and I want the sine. So remember, sine is opposite over hypotenuse. Opposites minus a half divided by 1, so that's equal to a negative a half. I could have just looked at this, and that's what I want you to get to. I want you to get to the point where you don't have to draw the triangle, where you can just get to the correct terminal side, look to the point, and say, oh, there's my sine value right there, negative 1/2. The sine of 210, or 7 pi over 6, is a negative a half. I don't have to draw the triangle. I don't have to do the opposite over hypotenuse. I can just tell by the ordered pair. So let's see if we can do that with the tangent of 270. Let's see what happens, because this one doesn't have a triangle. This one's kind of a tricky one. If you rotate 270 degrees, that puts you right here on the y-axis. There's no reference triangle with that. So to figure that out, we're going to have to do, remember, word definition, tangent theta is opposite over adjacent. And if you're catching on with these ordered pairs, this right here was considered the opposite side, because we were always dividing by 1. This was considered the opposite side, and this was considered the adjacent side. So if I'm looking for tangent, I don't need to build a triangle. I'm just going to say, okay, well, tangent of 270 degrees is, I'm going to look at my ordered pair. Here's my opposite side divided by my adjacent side. Well, I can't divide by 0, so it looks like to me the tangent of 270 degrees is undefined. All right, so let's decide what quadrants do we think the tangent's positive in. Well, if you're reading your little thing, it'll tell you right, your unit circle, it'll tell me right here where it's positive. How do I figure that out? Well, we know word definition of tangent is opposite over adjacent. And in our examples, we've been learning that this is the opposite side. This is the adjacent side in our ordered pairs. This is matching up with the sine value and the cosine value, which you could also say, since this is the opposite side, this was always the y direction and that was always the x direction. All those things are synonymous. They all mean the same thing. So basically, you're looking for a place where when you do the tangent and you divide the opposite side over the adjacent side, you end up with a positive. Well, that can only happen in the first and the third quadrant, because remember, in this quadrant right here, it's always a positive number and a positive number. So a positive divided by a positive would stay positive. And in the third quadrant, they're both negative. So a negative number divided by a negative number is also a positive number. So tangent is positive in the first and the third quadrant. In what quadrants is the cosine negative? Okay, well, let's put this back up here again. So remember, we have these ordered pairs. So X and Y, that's how we got these points on our unit circle. We are learning that the X value is the same thing as the adjacent side. The Y value is the same thing as the opposite side because we're in the unit circle and our hypotenuse is 1. This is not always true. It's just true for the unit circle. And then we're learning that also matches up with cosine theta and sine theta. Okay, so where's the cosine negative? Well, it looks like to me I'm looking where x values or the adjacent side are negative numbers. So if you come over here to your unit circle, it looks like to me that the x values or the adjacent side are negative right here in the second quadrant and right here in the third quadrant. So cosine is negative in the second and third quadrant. Okay, so what are the big conclusions we can draw from the unit circle? So first of all, a lot of it has to do with the ordered pairs. Everything has to do with the ordered pairs. So in your quadrants, if you were just to graph ordered pairs normally, the ordered pair, so the ordered pair in the first quadrant, so if I were going to do ordered pairs in the first quadrant, they would be positive and positive. Over here in the second quadrant, they would be negative and positive. And then down here in the third quadrant, they'd be negative and negative. And then in the fourth quadrant, they'd be positive and negative. Now, each one of those ordered pairs is going to be associated with a trig function. So this ordered pair point xy can also be referred to as the adjacent side or the opposite side or the cosine theta and sine theta. That's really important that you understand that. And then tangent theta can be considered the opposite side. Word definition is the opposite side over the adjacent side. So since we're working with points and all of these are synonymous, I could actually write tangent theta as y over x, or I could also write it as sine theta over cosine theta. That's a trig identity. Tangent theta is equal to sine divided by cosine. So we know the opposite over adjacent side, but we could extend that to y over x or sine over cosine. So any point that's on your unit circle, you can use that ordered pair to find all 6 trig functions. Well, then how do I find the other trig functions? Because I only see cosine and sine and tangent. Well, in this ordered pair then, the reciprocal of the cosine, this would be 1 over the cosine. 1 over the cosine would be the same thing as the secant. So let's write it this way instead. So secant theta is going to equal 1 over cosine theta. So whatever you have right here on your unit circle, let's say, well, maybe I'll go back a slide. Let me finish the definitions and then we'll put a slide up and we'll do an example. So secant is 1 over cosine, and then cosecant is the reciprocal of sine, and tangent theta, cotangent theta is the reciprocal of tangent theta. Okay, let me pull up a unit circle here and I'll show you how that works with the secant, cosecant, and the cotangent. Okay, so I've kind of set up some questions here. You don't have these in your notes, but this will kind of help you. It's in the homework, so this will kind of help you figure out how do you do the reciprocal functions. So let's try to see if we can figure out how to do secant of 60. Before we do that, though, let me highlight, you're going to have to memorize what all of these ordered pair values represent. So what do I mean by that? You're going to have to know that xy is adjacent over opposite, or cosine sine. The nice thing about this is that it's all in alphabetical order. X before y, adjacent before opposite, cosine sine. They are all in alphabetical order if you're looking at the first letter of everything. So that's an easy way to remember it. If you're like, oh man, which one is cosine, which one is sine? Just remember, it's alphabetical order. C comes before S. Which one's the adjacent side? Which one's the opposite side? Alphabetical order. Adjacent side first, opposite side second. So that's one little trick to help you to remember how they're ordered in their ordered pairs. Okay, so back to our secant of 60 degrees. So we start here. We got to figure out where that point is. So we always start on the positive x-axis. We rotate. We find out what our terminal side is. We follow it to the point. Okay, I'm looking for secant. There is no secant in the ordered pair. It's a cosine and a sine, or an adjacent over an opposite. So I know that secant is the reciprocal of cosine. In this ordered pair, cosine is a half. So what is the reciprocal of a half? It's 2 over 1. So what's my answer? 2. So secant of 60 degrees is 2. Okay, cotangent. Let me put the tangent over here just to remind you. Tangent is opposite over adjacent, or we could also use it as sine over cosine. Okay, so if I'm going to do cotangent of 210 degrees, I'm going to start on the positive x-axis. I'm going to rotate to 210 degrees, which puts me right here to my terminal side. I'm going to draw that terminal side in. I'm going to find the point that's associated with that. And then I'm going to figure out what cotangent is. Well, cotangent is the reciprocal of tangent. So if tangent is sine over cosine, then I'm going to want to do cosine over sine. Now, let's just talk about this for a minute. You guys are probably not very excited about doing the square root of 3 minus the square root of 3 over 2 divided by a negative a half. I'm not too excited about doing that. A fraction over a fraction, well, these two are going to reduce. How about instead of writing as a fraction over a fraction, since I know in the very beginning the 2's are the same and they're going to reduce, let's just look at negative square root of 3 and negative 1. So you'll get the same answer. I mean, I wrote the fraction over here to the right, and if I reduce it, it turns out to be the square root of 3. But look at how much easier it is if I say cotangent of 210, and I come over here, and I do the adjacent side, and I know that my 2's are the same, so I'm going to disregard them. So I'm taking my adjacent side, or my cosine, and I'm going to say, well, that's minus the square root of 3 divided by the opposite side, or the sine, negative 1. You get the same answer. So much simpler. And that's going to be true all the way around the unit circle, because if you look, they're all divided by 2. So you really only need to worry about the numerators when you're comparing cotangent and tangent. You don't have to do the whole fraction divided by the whole other fraction. Okay, cosecant of 5 pi over 3. So once again, I'm going to start on the positive x-axis. I'm going to rotate until I get to 5 pi over 3. So rotating around until I get to 5 pi over 3, which is right here. Going to draw that terminal side in, find that point, and cosecant is the reciprocal of sine. This is the sine. So if I was going to do reciprocal of that, I would just write that as 2 over minus the square root of 3. I just did the reciprocal. Okay, we need to fix that. You can't leave the answer like that. So number one, you don't have a negative in the bottom. and then you need to rationalize. So you end up with negative 2 root 3 over 3. So that's the answer. Negative 2 root 3 over 3 divided by 3. Okay, so hopefully that's enough information to help you to start to use the unit circle. If you're still having a hard time figuring out what the points represent, how do you know what to use what, come in and talk with me. This is a really big idea. This idea extends into Honors Math 3, calculus, huge idea. And it's not, mathematically, it's not hard. It's a little more conceptually, what you have to figure out is what's going on conceptually, not necessarily mathematically hard problems. It's more conceptual stuff. So if you need to come in and talk with me, come in and talk with me and I'll help you through them some more.